Hello everyone, and welcome back to ECS 10. In this video, we're going to be talking about the basics of using the interpreter. Namely, we're going to be talking about how to open and run the interpreter through either idle or the command line, how to use the interpreter to do some basic math, how to use variables to store values, and about the types of variables. So our first step is going to be opening the interpreter. If we want to run the interpreter through idle, we're going to search for idle and open it up. And there's our interpreter ready to go. If you're on Windows and you want to run it through the command line, first go to Windows, open up the command line by searching CMD and opening the command prompt. And then if you'd like to run the interpreter, type Python and you're good to go. Finally, if you're on Mac or Linux and want to open the interpreter through the command line, go ahead and open your terminal. And then when it pops up, type Python 3. And you're good to go. When you're done with the interpreter at the end of this lesson and would like to quit, you can type exit with parentheses, and that'll close down the interpreter on the command line. Same thing will also work in Windows. I'm going to be using idle just because it's a bit more colorful and a bit more pretty to look at, but they all will do the exact same thing. So the interpreter is really useful for doing math and for testing out little snippets of code that you want to see if they work or not, or what's going to happen. So all the basic math operations that you think would work, do work. So if we want to do 3 plus 5, that works, and we get 8. If we want to do some subtraction, 8 minus 6, well, we're going to get 2. Multiplication, that's great. You don't need to leave the spacing in between the numbers and the operators. It just looks nice. So you could do something like 10 divided by 7, get 1.42. You might think that the caret operator is going to do some exponentiation. So you might do something like 3 to the 9 or 3 to the 3. But that gives us 0. And the caret operation does bitwise XOR. Don't worry about what it's exactly doing. It's just not exponentiation. If you want to do exponentiation, you need to use 2 stars in a row. They need to be right next to each other. So 3 to the 3, that's 27, which is exactly what we expect. And there are 2 other operators that you might not think of. One of these is integer division. So if we do 12 slash 3, we're going to be asking how many times does 3 evenly go into 12. If we just do 1 slash 12 divided by 3, well, we're also going to get 4 because 12 divides evenly into 3. So maybe we pick 11 slash 3. 11 or 3 evenly goes into 11 3 times. But if we do 11 divided by 3, we're going to get 3.666666666 repeating. The other thing that we can do is remainder, and that'll be what's the remainder after we divide, and that's the percent sign. So if we do 11, the percent sign is referred to as mod. 11 mod 3, we're asking what's the remainder after we divide 11 by 3. So after we divide 11 by 3, well, we're going to have 2 left over. That's your basic math. These expressions can be as long as you want. So if you want to do 5 plus 5 minus 6 times 9 minus 33, well, we can do that. And you can keep going as long as you want. And you can use the parentheses to control the order of evaluations. So, you know, normally if you do 4 plus 5 times 2, the order of operations takes precedence just like normal. So we're going to do the 5 times 2 first and get 14. But if we want to do the 4 plus 5, just like in normal math, put parentheses around it. 4 plus 5 times 2. And then we're going to be doing that multiplication after we do the addition. I'm going to go over here to my shell, and I'm going to restart my shell just so it hopefully will clear everything off, which it didn't. So the next thing I'm going to talk about are variables. Sometimes your expressions and your values you have might represent real things, like maybe your height or your age or how much money is in your bank account. And we can save these values inside of variables. The syntax for doing this is going to be your variable name, or maybe example we do our savings, and then the value that we want to put into savings. So we might do savings is equal to $5,000. And you notice that nothing got printed out. That's normal when we're doing variables or assigning values to variables. If we want to see the value of the variable, we can just type its name. So our savings has the value of 5,000. And this is a really good abstraction for us because we're allowed to think in terms of these variables just like you've done in algebra and work with them to solve problems as opposed to always having to work with these hard-coded values. Now there are some restrictions on the names of variables. This restriction is that your variables have to be made up of alphanumeric characters and underscores, and they can't start with a number. Alphanumeric just means that they're made up of numbers and letters, and again, you also are going to be able to use the underscores. Variables also are case sensitive, so high with a capital H and high with a little h, those are going to be two different variables. And it's really important that when you choose names for variables, that you use really descriptive names, because this is going to make thinking about your problems a lot easier. If we're going to be working with our savings, writing the word savings is a lot easier to think about than just the letter S. S could represent anything. Maybe it's savings, maybe it's shoe size, maybe it's the number of stars. But savings makes a lot of sense if we're talking about how much money is in your savings. Over here, we have some examples of valid variable names. You might have Rocket Out, again, has only letters in it and underscores. You Are the One, underscores, letters, and numbers. Coast to Coast, letters and numbers, so we're all good. Shout, it's all capital, which is perfectly fine. Whisper, all lowercase, also perfectly fine. Then down here we have some invalid variable names. One and only isn't good because this guy starts with the number 1. What's not okay because he has the exclamation point, and the exclamation point is not alphanumeric. You and me also doesn't work because there are spaces in between the names of the variable, and spaces aren't alphanumeric. They're not letters or alphabetical characters. If we try doing some of these bad variable names inside the interpreter, it's going to give us errors like one and only. It says invalid syntax. It's not going to like that, and it's going to complain at you all day as long as you try to choose invalid variable names. The other cool thing about variables is, like we talked about before, they can appear as part of expressions. So we've already come up with our savings over here, and you can see that we assigned savings the value for 5,000, just like we did back in the interpreter. And when we go to use our variables as part of our expressions, as you see down here, the value of the variable is going to get substituted in. So I'm going to finish the code over here on the right-hand side. So we might say our property is worth, property, capital P, property is equal to 200,000. That purple name lets you know that it was one of the built-in names that Python uses, and you don't want to name your variables the same as those because you might break how Python works a little bit. Then we might have our mortgage equal to 100,000, paid off halfway. It's pretty nice, but we might still have some loans. Maybe these are your student loans. $12,000, and so you might say our debt is equal to how much we have in our mortgage plus how much we have in our loans, and our assets are equal to our savings that we have plus the value of our property. Oops, I misspelled savings. Notice that here we use savings with a lowercase s, but here I use savings with a capital S, which is why I got angry at S, because again, capitalization matters. So assets is equal to savings with little s plus property. And again, if we want to see the values of the variables, we can type their names back out. So here's our assets, and our debt. And if we wanted to know our net worth, well, that's equal to our assets minus our debt. And you can see this is how much money we'd be worth if we had these various values in terms of our savings, our property, our mortgage, and our loan, and our debt. Or savings, property, mortgage, and our loans. One really important thing and a mistake that's really easy to make is to think that the equal sign means equal, just like it does in math. You don't want to read the equal signs as equals. You want to read it as is assigned to. And this will help prevent you from making mistakes. So here on the right-hand side, we don't want to say A is equal to 10. We want to say A is assigned the value 10. Take the value 10 and put it over into A. Here we want to say B is assigned the value of A. Now when the interpreter goes to evaluate this expression, it's going to say, oh, here's A. What's A's value? It's 10. Go put 10 into B. So B and A will have the same value. Here, if we do B is assigned the value 8, we're going to take the value 8 and put into B, right? B currently had the value 10, but now we're saying, hey, let's replace B's value with the value 8. But this is not going to change A's value at all, because we didn't say A is assigned to anything. We can even run this in the interpreter. A is assigned the value 10. B is assigned the value of A. B is also 10. We say B is assigned the value 8, and we look at B's value. It's 8, and A's value hasn't changed because A and B are two completely separate variables. Only the variable on the left-hand side of the equality sign can change. The other variables that show up on the right-hand side, their value cannot change at all. Another mistake, again, if you're thinking about equals, well, 5 equals B and B is equal to 5. Those both sound right when we say them out loud. But if we read this as 5 is assigned the value of B, this doesn't make sense. So we want to say that, hey, 5 is assigned the value B, but B currently has the value 8. So you want to say 5 is assigned to be the value 8. But 5 is 5. 5's always going to be 5. 5 is never 8. So we don't want to change 5's value to 8, and we can't do that. And you're going to get this error if you try doing it. We can't assign to a literal. Because what the compiler is really, or the interpreter is really trying to do is 5 is assigned the value that's stored in B, 8. But I put 8 into 5. It doesn't work. 5 is a literal. It's literally the number 5 and can't change. So we can't put anything into it. The other thing to think about is that a variable's value can be used to update itself as part of an expression. So you can see a variable appearing both on the left and on the right-hand side of an equality sign. This actually happens really frequently in terms of programming because variables get updated based on their old value a lot. And I want to introduce you to it so you don't get confused by it. When we do this, what's going to happen is the value on the right side, the right-hand side of the expression, will be evaluated first. So here we're going to say A plus 5. Well, A's value is currently 10, so we get 10 plus 5. That's going to be 15 after we finish evaluating the expression and doing the addition. And then we're going to go put that 15 into A. So after we do this expression, A's value is going to be 15. Or here, if we do B is 12, and then on the next line we said B is assigned the value of A plus B, well, A's value is 15 from this previous line, B's value is 12 from the previous line, we do 15 plus 12, we get our 27, and then B's value is updated to 27. Running that all over here in the interpreter, A is 10. A is assigned the value of what A currently has plus 5 more. So A is now 15. B is assigned the value 12. You can see it's 12. B is assigned the value of A plus B. So add A and B together, whatever their values currently are, which in this case is 15 plus 12. We're going to get 27 and store that result back into B. You can see B is now 27. Final thing that we need to talk about is that variables have types, because Python is a strongly typed language. The type of the variable is based on what's stored in the variable. And if we want to get the type of a variable, we then do type and then the name of our variable. So if we ask, for example, what's the type of A, we're going to see that A's type is an int. If we had C and it's equal to 35.4, well, the type of C is a float. So you can see that Python uses two different types to store either whole numbers, which are called integers, or real numbers, which are represented using floats. One thing you might be curious about is what happens if you add a float and an integer together. Well, what are you going to get? So if we ask for what's the type of A plus C, it's going to be a float. And if we look at A plus C, this will make sense because you can see that A plus C is 50.4, and that's a real number. So most of the time, the way to think about what's going to happen, if you do integers and integers, most of the time you end up with integers, unless you're doing division. And if you're doing integers and floats together, you're always going to end up with a float again. So that's it for this first episode. Again, if you're done and you want to leave the interpreter, you can type exit, and then I'll close this out. Yep, want to kill it, I'll close the window, or you can just click on the X button in the upper right hand corner of the screen. That'll also close it. And next time, we're going to talk about how to write our first program and get a little bit deeper into what Python is. So I'll see you guys all in the next video.